Welcome to Astronomy Daily, where we bring you the latest in space and astronomy news. I'm Anna, and I'm thrilled to be your guide through today's cosmic journey. Coming up on today's episode, we'll explore some major developments spanning the entire space sector. We'll look at how SpaceX, ULA, and Blue Origin are sharing a massive $13.5 billion in military launch contracts, marking a significant shift in national security space access. Then we'll follow the adventure of 4 space tourists who just completed a groundbreaking flight circling our planet above both poles, a true first in human spaceflight history. We'll also check in with the hardworking crew aboard the International Space Station, where cutting-edge robotics experiments and crucial medical research continue as they prepare to welcome new crewmates. Plus, we'll dive into fascinating astronomical research, including how scientists are essentially listening to stars through their vibrations to understand their inner workings, and a jaw-dropping discovery from the James Webb Space Telescope of an ancient galaxy that's challenging everything we thought we knew about galactic evolution. So strap in as we blast off into today's cosmic news roundup. The U.S. Department of Defense has made a historic move in the space sector, awarding a combined $13.7 billion in launch service contracts to SpaceX, United Launch Alliance, and Blue Origin. This landmark decision marks the first time 3 companies will share responsibility for launching high-priority military and intelligence payloads, significantly reshaping the national security launch landscape. SpaceX emerged as the leading contractor in this arrangement, securing $5.9 billion in anticipated awards. ULA followed closely with $5.4 billion, while Blue Origin secured nearly $2.4 billion. Together, these aerospace giants are expected to conduct 54 launches for the Pentagon between fiscal years 2025 and 2029. General Chance Saltzman, Chief of Space Operations for the U.S. Space Force, emphasized the strategic importance of this investment, calling it the foundation of both economic prosperity and national security. These contracts fall under the National Security Space Launch Phase 3 Lane 2 procurement, which focuses specifically on complex missions to high-energy orbits with enhanced security requirements. The distribution of these 54 projected missions reflects the current capabilities and trust placed in each provider. SpaceX will carry out the lion's share with 28 launches, approximately 60% of the total. ULA will handle 19 missions, about 35%, while Blue Origin is slated for 7 launches. Interestingly, Blue Origin's assignments are contingent on certification of its New Glenn rocket, which has flown just once so far. This 3-provider approach represents a significant shift in the Pentagon's strategy. The inclusion of Blue Origin introduces more competition into a market that SpaceX has dominated since the previous round of contracts in 2020. Despite New Glenn not yet being certified for national security missions, Space Force officials have expressed confidence that the rocket will be ready by the time Blue Origin's assignments begin. The Phase 3 acquisition strategy employs a dual-lane approach to ensure diversification. Lane 1 targets less risk-averse, commercial-like missions, while Lane 2 focuses on high-stakes missions demanding elevated performance and security standards. Under these contracts, all 3 companies must meet stringent mission assurance requirements and participate in joint integration efforts with government teams. This development builds on the Pentagon's ongoing efforts to eliminate dependence on Russian-made rocket engines while fostering a competitive domestic launch market capable of meeting evolving space requirements. The first round of mission assignments under these new contracts will be announced later this year, with launches expected to take place from fiscal year 2027 through 2032. Next, let's get a wrap on the major story of the week. In a remarkable achievement for commercial spaceflight, 4 space tourists have safely returned to Earth after completing a groundbreaking orbital journey circling the globe above the North and South Poles. This historic mission, which concluded with a Pacific Ocean splashdown this past Friday, marks both the first human spaceflight to traverse this unique polar route and the first Pacific splashdown for a crewed spacecraft in 5 decades. Bitcoin entrepreneur Chun Wang privately chartered the SpaceX Dragon capsule for this extraordinary adventure, though he declined to reveal the price tag for the 3.5-day journey. Wang carefully selected his 3 fellow travelers: Norwegian filmmaker Jannicke Mikkelsen, German robotics researcher Rabea Roga, and Australian polar guide Eric Phillips. Together, they experienced views of our planet that no human had witnessed before from this orbital perspective. The crew's Dragon capsule featured a specialized domed window providing breathtaking 360-degree views of Earth's polar regions and everything in between. Roga described the polar landscapes as epic and likened them to another kind of desert that extends endlessly across the horizon. Meanwhile, Mikkelsen documented the journey extensively, bringing along professional camera equipment to capture their unprecedented vantage point. The journey wasn't without its challenges. All 4 passengers experienced space motion sickness after reaching orbit, according to Wang's social media updates. However, by the second day, they had adjusted to the weightless environment and eagerly opened the window cover right above the South Pole to take in the extraordinary view. Beyond sightseeing, the crew conducted meaningful scientific work during their brief mission. They performed the first medical X-rays in space as part of a test procedure and completed 24 additional science experiments. The mission was named Fram 2 after the Norwegian sailing ship that carried explorers to the polar regions more than a century ago. In a touching tribute, a fragment of the original ship's wooden deck accompanied the crew to space. SpaceX noted that this mission also marked a shift in their operational approach, as they've decided to switch future splashdown sites from Florida to the Pacific Ocean for safety reasons. This ensures that any surviving pieces of the trunk section, which is jettisoned near the end of flight, will fall harmlessly into the ocean. Historically significant, the last space travelers to return from orbit to the Pacific were the 3 NASA astronauts from the 1975 Apollo-Soyuz mission. This pioneering polar orbit journey represents another significant milestone in the rapidly evolving landscape of commercial space tourism, demonstrating the expanding capabilities and unique experiences now becoming available beyond traditional government space programs. Have you ever wondered what they do on the ISS from day to day? Well, I'll tell you. It's been a bustling week aboard the International Space Station as the Expedition 72 crew balances cutting-edge research with preparation for upcoming crew changes. The orbital laboratory continues to serve as humanity's premier microgravity research platform, with activities spanning from robotics to human physiology studies. NASA astronauts Don Pettit and JAXA's Takuya Onishi collaborated on an innovative robotics experiment using the station's Astro B free-flying robots. These cube-shaped autonomous devices, equipped with tentacle-like grippers featuring gecko-inspired adhesive pads, were tested on their ability to detect, maneuver toward, and capture objects in microgravity. The technology demonstrates promising applications for future satellite servicing and space debris removal, critical capabilities as we work towards sustainable space operations. Meanwhile, the unique environment of space continues providing valuable insights into human health. NASA flight engineer Nicole Ayers conducted exercise physiology research, pedaling on a specialized cycle while connected to sensors and breathing equipment. The data collected helps scientists understand how the cardiovascular system adapts to weightlessness and guides the development of more effective exercise protocols for long-duration space missions. Another fascinating experiment involved Onishi wearing a specialized thigh cuff designed to alter fluid distribution in the body. This research tackles one of spaceflight's persistent medical challenges, the fluid shift toward the head that can cause increased pressure in the eyes and brain. Ayers assisted by using ultrasound equipment to measure blood flow in Onishi's legs, evaluating the cuff's effectiveness. Maintaining the station's complex life support systems remains a priority. Ayers, Pettit, and NASA's Anne McClain performed critical spacesuit maintenance in the Quest airlock, checking for oxygen leaks, replacing electronic components, and servicing life support gear. These routine but essential tasks ensure the suits remain ready for emergency situations or scheduled spacewalks. On the Russian segment, cosmonauts focused on environmental monitoring. Roscosmos flight engineer Ivan Wagner collected microbial samples from various station surfaces to better understand how microorganisms adapt to spaceflight conditions, research crucial for maintaining crew health during future long-duration missions. Fellow cosmonaut Kirill Peskov measured carbon dioxide levels and performed maintenance on communications equipment. As the current crew continues their orbital work, a fresh trio of spacefarers is making final preparations for launch. NASA astronaut Johnny Kim and Roscosmos cosmonauts Sergei Ryzhikov and Alexander Zubritsky are scheduled to lift off aboard the Soyuz MS-27 spacecraft on April 8th from the Baikonur Cosmodrome in Kazakhstan. Following a 3-hour journey to catch up with the station, they'll dock to the Prishal module and begin an 8-month scientific mission. Meanwhile, Station Commander Alexei Ovchinin is readying the Soyuz MS-26 spacecraft for its return journey on April 19th, when he'll bring Wagner and Petit back to Earth after their extended stay in orbit. This carefully choreographed crew rotation ensures continuous human presence aboard our outpost in space, maintaining the unbroken chain of occupation that now extends beyond 2 decades. Next up today, stars don't just shine, they hum with hidden vibrations that could unlock secrets about their inner workings. Scientists have discovered a fascinating new method to study what they call stellar quakes, which are ripples of gas on a star's surface that offer tantalizing clues about what lies beneath. These stellar quakes function remarkably similarly to earthquakes here on our planet. When hot gas rises, cools, and sinks in a churning cycle within a star's convective envelope, the turbulent outer layer, it creates vibrations that propagate throughout the entire stellar body. By detecting subtle variations in a star's brightness, astronomers can identify these acoustic oscillations. Stellar quakes happen in most stars that have a bubbling outer layer, like a pot of boiling water, explains Claudia Reyes, who conducted the research at the University of New South Wales. These bubbles of hot gas rise and burst at the surface, sending ripples through the entire star. Just as each musical instrument produces its own distinctive sound, each star vibrates with unique resonant frequencies determined by its internal structure and physical properties. Larger stars produce deeper, slower vibrations, while smaller stars vibrate at higher pitches. By analyzing specific aspects of these vibrations, such as what scientists call small frequency spacing, researchers can estimate a star's hydrogen fuel reserves, essentially determining how far along it is in its life cycle. The research team focused on measuring stellar quakes in 27 stars from Messier 67, an open cluster containing over 500 stars with an age similar to our Sun. This cluster offered an ideal laboratory since it contains many stars at different evolutionary stages, but with similar chemical compositions. What made their findings particularly exciting was the discovery of a stalling frequency, a point where a star's vibrations stop changing and repeat the same note. This stalling correlates with the lower boundary of the star's convective envelope, providing astronomers with a powerful new diagnostic tool to estimate stellar masses and ages with improved precision. Stars are like fossil records that carry information about the environments in which they formed, noted Reyes. By studying them, astronomers can piece together the story of our galaxy. This breakthrough in stellar seismology promises to enhance our understanding of stellar evolution and galactic history. By decoding the subtle music of the stars, scientists are developing a more accurate cosmic timeline and gaining insights into the fundamental processes that drive stellar life cycles, including what might eventually happen to our own sun. Finally today, let's check in with an old friend. The James Webb Space Telescope has made another groundbreaking discovery, uncovering a colossal spiral galaxy that's challenging our understanding of galactic evolution. Nicknamed Big Wheel, this enormous galaxy existed just 2 billion years after the Big Bang, during what should have been the cosmic equivalent of childhood for most galaxies. The discovery comes from astronomers at the University of Milano Bicocca, who found Big Wheel near a quasar, an extremely powerful and active supermassive black hole. Located a staggering 11.7 billion light-years away, this ancient galaxy earned its nickname from both its impressive size and remarkably fast rotation. What makes Big Wheel so extraordinary is its scale and maturity. It's approximately 5 times more massive than our own Milky Way and stretches across 100,000 light-years. Using the telescope's near-infrared spectrograph, researchers confirmed that Big Wheel is a fully formed rotating disk, with characteristics typically found only in much more developed galaxies. The galaxy's rotation curve shows a pattern consistent with mature spiral galaxies we observe today. Its velocity increases as you move outward from the center, reaching several hundred miles per second, remarkably similar to galaxies that have had billions more years to develop. This suggests that, despite its youth, Big Wheel was already behaving like a fully mature galaxy during an era when most galaxies were expected to be small and in their earliest developmental stages. This galaxy is spectacular for being among the largest spiral galaxies ever found, which is unprecedented for this early era of the universe, explains Charles Steidle, the study's lead author and astronomy professor at Caltech. So how did Big Wheel form so quickly? One clue may lie in its cosmic neighborhood. The galaxy resides in an extraordinarily dense region of space, where galaxy concentrations are more than 10 times higher than the cosmic average. This crowded environment may have provided ideal conditions for accelerated growth through efficient gas accretion and frequent mergers with other gas-rich galaxies. We think this may open the door to understanding how some galaxies were able to bypass the usual slow process of star formation and grow to enormous sizes in the early universe, notes study co-author Sebastiano Cantalupo. Big Wheel's existence presents a significant challenge to current cosmological models, which don't predict galaxies of this size and mass so early in the universe's history. The discovery suggests that under certain conditions, galaxy formation might not be the gradual process scientists previously thought. Instead, some galaxies may experience dramatic growth spurts in environments rich with the necessary building materials. As astronomers continue studying this cosmic outlier, they may need to adjust their models to account for these accelerated development pathways. Big Wheel stands as a testament to the universe's ability to surprise us, even as our observational capabilities reach unprecedented levels of sophistication. And that wraps up today's episode of Astronomy Daily. From SpaceX securing military launch contracts to groundbreaking space tourism over the poles, from cutting-edge robotics research on the ISS to the discovery of stellar quakes helping us understand stars, and finally to the astonishing Big Wheel galaxy, challenging our understanding of cosmic evolution. The universe continues to amaze and surprise us. I hope these stories have sparked your curiosity about the vastness above us and the incredible scientific endeavors working to understand it. There's always something new to discover in the cosmos, and we'll be here to bring those discoveries right to you. I'm Anna, and it's been my pleasure being your host today. If you enjoyed this episode, I invite you to visit our website at astronomydaily.io, where you can sign up for our free daily newsletter. While you're there, you can catch up on all the latest space and astronomy news with our constantly updating newsfeed and listen to all our back episodes. We'd love to connect with you on social media as well. Just search for Astro Daily Pod on Facebook, X, YouTube Music, Instagram, and TikTok. Thanks so much for tuning in today, and remember to keep looking up. The universe is an endless source of wonder. Until next time, this is Astronomy Daily.